Hi, today I'm going to speak about database optimizations. First, we look at the definition of relational database. Relational database is a database that is made up of tables. A common misconception is that a relational database is about how each table is related to each other, but it is not the relationship between tables. A table is called a relation, and each row in the table is called a record, with unique ID called the key. The columns of the table hold attributes of the data, and each record usually has values for each attribute, making it easy to establish the relationship among data points. A relational database management system is a software for managing relational databases. There are many vendors who create RDBMS. Some of them are MySQL, MS SQL, Postgres, Oracle, etc. Let's see some of the database optimization techniques. Database optimization should start from the design phase. So, while designing entities, we have to ensure database tables are normalized. Normalization is a process of minimizing redundancy from a relation or set of relations. There are six levels of normal forms. We can see the first three normal forms. First normal form. A table is in first normal form if and only if it contains atomic attributes. It should not have any multi-valued attributes. For example, here in store 1 table, locations are stored as comma separated values, whereas in store 2, it is stored as separate rows. An advantage of having tables in the first normal form is we can use search criteria with atomic attributes easily. Here, we would be able to filter using store location easily, and also column can be indexed to make select perform faster. Second normal form. A table is in second normal form if and only if all the non-prime key attributes are fully functionally dependent on the primary key. For example, instead of storing employees and departments in the same table, we can split it into two tables. When the table is not in its second normal form, storage space will be wasted. When there are 1000 employees present in each department, then 1000 records with duplicate department name will be created. It suffers from three anomalies: insertion, deletion, and updation anomalies. Third normal form. Very often, when a table is in second normal form, it will already be in third normal form. A table is in third normal form if and only if all the non-primary key attributes are fully directly dependent on the primary key. There is only a subtle difference from the second normal form. While the second normal form focuses on full dependency on key, the third normal form focuses on eliminating transitive dependency. That is, all non-key columns should be directly dependent on key. For example, here the column zip depends on ID, column country depends on zip column, although column country depends on ID transitively through column zip. It is not a direct dependency. Hence, we have to move zip and its dependent column to new table. Third normal form has the same disadvantages as the second normal form. Avoid null values. A null is an indeterminate value, so a column which can have null values should be used with caution. For example, to filter rows that contains null value in a particular column, it should be filtered with this null check and not equal to null check. Here, first query will not select any rows even if there are rows with null values. The second query is the correct way. Similarly, we cannot use null values in condition as the third query will not return any rows because null can be any value. Using subtypes. Using subtypes and supertypes avoids null values. It saves disk space. For example, instead of having a single employee table for maintaining permanent and contract employees, we can have one supertype employee and two subtypes permanent and contract employees to maintain the data easily. Also, we can avoid some arbitrary values such as December 2009 or null values. Do as much work as possible in database side itself. Instead of fetching intermediate results from database in application and determining the final result using procedural logic in application, we can do as much work as possible in the database. This will avoid programming bugs. For example, to count the number of students by their height range, instead of fetching all rows from the student table and processing in the application side, we can write a query using case when syntax. We get range values from the height columns in the query itself, and by using aggregate function, we can count the students in each range. Minimize the round trips between application and database. Try to use the same database connection in the application. For example, an application which opens and closes the database connection for executing each batch script runs slower than when it has a single database connection until all batch scripts get executed because Opening and closing database connection is a heavy operation. We should try to avoid queries used for validation before performing the actual operation. We should try to reduce the number of queries the application makes to the database. For example, for implementing purchase functionality, first we may write a query to check whether user with input ID is present in the database. Then we will write a query to get account records for user with input ID and input card. We check whether the user has more balance than purchased amount and the card has not expired. Finally, we update the balance. In the update query, we just update the balance column for the given user ID and card. Instead, we can use a single update query where it has all the validation check in the form of search criteria. If the number of rows affected by update query is 0, then we can execute another query to get the appropriate error message. After executing the second query in the right side, if no rows are written, then there is no user with input ID. If rows are written, we can check if there is a valid account with future expiry date and balance. So instead of doing this in three queries, we have reduced it to two queries. And for valid inputs, only one query will be executed. Use truncate to delete the entire table instead of delete. If we want to delete all rows in a table, we should use truncate as it is faster than delete. It is faster because it does not log individual row deletion and does not fire triggers. Mostly, truncate is used to delete the temporary tables. Avoid creating temporary tables as much as possible. For example, here we need to find the total bonus amount for employees. Bonus will be 10% of employee salary. The employee eligibility for getting a bonus is that employee joining date should be before 1st March 2022 and salary should be less than or equal to 8,000. Also, if an employee bonus is more than 500, then bonus will be 500. Here we are creating a temporary table first, which will have the columns employee ID and bonus, and it will contain all the records of employees whose salary is less than or equal to 8,000 and joining date is less than 1st March 2022. Then we can fetch all the records from this temporary table and calculate the sum of bonus, replacing all the bonuses greater than 500 with 500. Then truncate or delete the table. Instead, we can do this in single query as mentioned in the right side. Inside the subquery, we have two select statements. The first select statement calculate the bonus for employees whose salary is less than or equal to 5,000. In the second select statement, we assign 500 as bonus to all the employees whose salary is greater than 5,000 and less than or equal to 8,000. This query will return the answer directly. When we use functions in indexed columns for search criteria, then indexing becomes useless. For example, to find all persons with first name Abdul Kalam and last name as APJ, since this is case sensitive, when the input comes from the user, we will first change all characters to uppercase and run this select query. When we have an index for first name and last name column, and when we use functions, the index becomes useless. Instead, we can store names in uppercase in database so that we don't have to use functions, or we can use functional index as some DBMS support this functionality. Indexes needs more storage and has high maintenance cost. We should not create indexes for columns which are not used in search criteria and join. We should design the database in a such a way that update operations are not performed often in indexed columns, or more modification operations are not performed in tables with more indexed columns, as it will affect the performance. In some DBMS, all primary key and foreign key columns are indexed by default. We can use composite index for multiple where class conditions. For speeding up range scan queries, we can use clustered index. For example, for searching all records with power output greater than or equal to 100 from table speaker, we can create clustered index on power output column and run this select query. As already mentioned, indexes take up a lot of storage space and have high maintenance cost. We should create an index for necessary column only once. When we have a composite index for two columns, say A, comma B, then an index for column A that is already included in the composite index is not required. Here, the order of columns in the composite index is important. For example, when we have a composite index with columns first name, last name for table person, then a separate index for first name is not required, as the same composite index will be used for searching the first name column alone. When we use system generated keys, then DBMS maintains a sequence table to get the next number for the primary key column. When DBMS is used concurrently using many user sessions, then there may be contention during locking of sequence tables. We should try to avoid using system generated keys when we do not have the need to use surrogate key. For example, here the email field is a unique field. If we can use email as primary key, then an extra ID field is not necessary. Avoid correlated subqueries. Whenever we write subqueries, we should try to write it as an uncorrelated subquery. For example, in an e-commerce website, when we want to list all customers of particular city who have purchased a particular product in last week, we can use the select query in the left side. Here there are four tables joined using their IDs, and there are two more conditions for product name and purchase time. This is a correlated query since c.id is accessed in subquery. For every customer record with Chennai location, the subquery will be executed. It is like having nested for loops in programming. If there are more customers at that location, then this query will take time. We can rewrite the same query with uncorrelated subquery. The performance of the query in the right side will be better than the performance of the query in the left side since subquery will be executed only once. Modify the existing query carefully. Adding an extra search criteria with an unindexed column could change the query performance drastically. For example, when we have a composite index, first name comma last name, and when we run a query that uses columns in composite index, then performance will be faster. Later, when we decide to change the query and add an extra search criteria without updating composite index, will affect the performance. Try using where class and distinct keywords, avoiding aggregate functions and having class, as where class filters the data early, making the query run faster. For example, here we have a query to select all customers with an order amount greater than 0 and an order date before 1 month. We can avoid unnecessary use of group by and aggregate functions. Instead, we can use the query mentioned in the right side. Use exist instead of count of star greater than 0 since DBMS has to search the entire table to get the count. For example, instead of getting the count and checking in the application code whether the counter is greater than 0, we can simply run the exist query mentioned in the right side. Thanks. If you find this video valuable, you may share with others. If there are mistakes, please mention them in the comment section.